Okay, everybody, this is chapter 5, lesson 3. We are looking at triangles and be able to prove that they're congruent, but we're going to try to take shortcuts to be able to do that. So previously we had to say that all the angles were equal and all the sides were equal to say that triangles are congruent. But because triangles are pretty unique, I only need a little bit of information to be able to prove that they're going to be congruent. So there's two different types that we're going to learn about today in this lesson, and then we're going to save a couple more for other lessons. All right, so in this particular one, if you guys would be able to highlight that, be able to prove that triangles are congruent by SSS, or side side side. So if we could go ahead and just highlight all this right here. If I can prove that all three sides of a triangle are equal to all three sides of another triangle, then I can say that the triangles are congruent. So then I can also add then all the angles are congruent without having to do anything about it. Okay. Big thing in this particular one that we deal with in side side side, you're typically going to have something to do with reflection. Okay, we're going to be looking at two triangles. They might be connected, so that means they're sharing a particular side. So therefore, the two triangles can be, or at least I could say two of the sides are going to be equal because they're reflexive. They're equal to themselves. Okay, so that'll be a big one for you in this particular one when we're trying to prove that triangles are congruent. Okay. So if we take a look at this first proof here that they got for you, there will be a lot of proofs. They're doing a flow chart proof, but we don't need to do that. If you could just go ahead and kind of sketch a two-column proof right here. All right, we're going to take what's given to me first. First off, QRS is an isosceles triangle. That means that two sides are equal. So in this case, they're telling me that QR is equal to SR. So I'm going to show that's equal. So QR equal to SR, and that's given. They also tell me the ray RT bisects QS at point T. So that means that if, bisector, if we remember what that means, it cuts something into equal halves. Well, I need to state that, okay? So I'm going to say here that QT is going to be equal to TS by the definition of a bisector. Okay, it was given to me, but I have to now state what is equal after that's been done. Okay, so I could do that. So if you look at that now, I've got two sides of the two different triangles are equal to each other. I just need the third because I need to prove that these triangles are congruent. They've just taught us about side, side, side. So can I get a third side? Well, I reminded you that, in this particular one, I got that ray, but that ray is really the third side of both triangles, okay? RT is part of both of the triangles I have to prove that are equal. So therefore, those two sides are the same, and therefore they're going to be equal, and that's by the reflexive property. And now that all three sides are equal, I can say by this new rule that we just learned that the triangles are equal. So taking what they wanted me to prove, triangle QRT is congruent to triangle SRT by this new rule, side, side, side. Okay? Just taking that new rule and getting the things I need for it and throwing it down. We know what a bisector does. It cuts stuff into equal halves. Stated. I know what the reflexive property is. Something's equal to itself. Stated. And that gave me this new rule. Okay. So not too hard. You got to know your stuff. See it. Throw it into your proof. You're going to be okay. All right. Taking a look at this particular one here. Sorry, I got to go to the next page. They want me to go ahead and graph these two triangles on the graph, okay? So I'm going to go ahead and give you a second to do that. And label them too. with the letters. And I did that. Okay, now that one, and I got this one. Okay, they want me to prove these two triangles are congruent. Now, the only way I can do that I know right now is show all the angles are equal and then all the sides are equal, or we just learn, hey, I just need the sides. So in this particular case, I would have to do the distance formula. I'd have to find the length of all the sides of each triangle and see what the corresponding ones were and see if they're the same. So this one I got a little bit of math to do. I've got to do this 6 times basically to be able to prove that the triangles are congruent. And I've got to match up matching sides. So just an example, if you write this down, please, I'd have to find that side JK would be congruent to side QN. I'm going back to what they're telling me here. The 2 triangles are congruent, but they want me to prove it. So I've got to keep corresponding sides in this case, all right? So then I have to say that KL would be equal to QNP, sorry. And then I have to go back and say, or try to find if JL is equal to QP. Okay, so I have to do that. And that's a lot of work, okay, but I'm using the distance formula. Now remember, we can go ahead and maybe do the Pythagorean theorem on all sides. That would be acceptable. That's fine, the length of sides, doing something a different way. So just know that you can, but you got to know how to do the distance formula. And that's what they use in this particular example. So if we just take a look at the work they did for us, thank you very much. They found the length of those 6 sides that I told you. They all came out to be the same. Okay, so the corresponding ones, that little grid that I wrote up, the different sides came out to be equal. So now these are down here. I can now say that they are, the triangles are congruent by side, side, side. Okay, so they did the work for you. Thanks a lot, but you're going to have to know how to do that too to prove that it's the triangles are congruent by side, side, side. Okay. Okay, taking a look at this, they wanted you to do the same thing. They got these 2 triangles, so if we graph this here, do it right. We got this triangle here. Okay, that's A, B, and C. And then I got triangle here, here, and here. And that's EFG. Okay. They wanted me to once again prove that they're congruent by side, side, side. It's a yes or a no. I have to do the Pythagorean theorem or the distance formula. I think they went and did the distance formula here. Okay, so once I get to that, they did the work kind of down here for me. They're trying to match up sides that are congruent. So AB would have to be congruent to EF, BC would have to be congruent to FG, and AC would have to be equal to EG. And if you'll notice that the values they give you here, matching those up, you can tell that no, they're not congruent, or at least those 2 sides are not congruent. So I can't say that the triangles are congruent by SSS. Okay. So, you know, on a test, I'm probably going to give you one that is going to come out. You just got to do the work. It's kind of senseless to do all that work and find out they're not, but you have to be able to prove it. Okay. All right. And this think about, I usually skip these just because of time in class, but I did do this one. If both legs of a right triangle, so let's just sketch a right triangle here, because this leads us into the next rule that we're going to get. I got two right triangles, so just sketch them. Okay, and they said the legs. Now remember, these are the hypotenuses, so they're not the legs. They're parts of the triangle, but not the legs. So it's saying that both the legs of a right triangle are congruent to the same two legs of another right triangle, should the triangles be congruent. Well, I think this is common sense. It's going to be a yes, okay? But they're using this to kind of introduce us into the next one. And this is going to be another rule. I need just a few pieces to prove that triangles are congruent. Just like side, 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 you know, technically there's 6 pieces of triangles. If they're going to be equal, have to be congruent. Well, I only needed the sides in that previous one to do that. Here, kind of same thing. I only need 3 pieces to say that they're congruent. Okay, so moving here, if you guys will highlight this particular one. Okay, we're going to go ahead and highlight here. And they have this term, an included angle, so we're going to have to talk about that. Okay, so we're going to be able to prove that triangles are congruent by the side angle side, or just SAS. And so down here with this postulate, if you highlighted that too, if you guys could sketch 2 triangles, and let's label them. They can kind of look the same. Okay. And we'll kind of, let's define what included angle means. Okay, so if it's side angle side, so that sounds like I got 2 sides that are equal. So let's say I got side AB is going to be congruent to side EF. And let's say that BC is congruent to side FG. So now what does included angle mean here? Okay, in the definition, the included angle is the angles that are equal that are created by the sides that are equal. Okay, so I've got AB and BC creating angle B, and over here I got side EF is congruent to side FG, and they're creating the angle F. And then if F and B are congruent, then I can prove that these triangles are congruent by side angle side. So obviously this could happen in lots of different ways in triangles, but if the 2 sides are equal to corresponding sides of other triangles and they're creating angles that are both equal, then I can say the entire pair of triangles are equal. Okay. All right, so we got this playground apparatus. They want us to draw a 2-paragraph or 2-column proof, and we're going to prove that triangles are congruent. So if you take a look at the proof here and the figure, okay, they got a couple of these triangles congruent or highlighted, but they're telling us that in this fixture all the triangles are congruent, so we're going to take their word for it. Okay, but specifically they're saying KL is going to be side KL is congruent to side LM. Okay, showing that. They're also telling us that angle JLK is congruent to JLM. So let's show that. All right. So if in this one they kind of split the given up into the first 2 steps. So we're going to say that this is given 2, okay? But now what else do we say? Well, going back earlier in different sections we've done, we're looking, hey, do the two triangles I need to prove are congruent, do they share a side? And in this case, they do. So I could say that JL is equal to JL by the reflexive property. Okay. So that should be, automatic for us. We should see that, be able to say that right off the bat. Now I'm going to last step. Why are JLK and JLM congruent? Well, if you look at, I've got a side, an angle, and another side is congruent to a corresponding side, corresponding angle, reflexive side. I've got side, angle, side. The angles that were equal are made up by the two sides that are congruent. Okay. So the last step is typically the rule that we're learning, and we've shown that. Once again, we've used the reflexive property. I hope that we're understanding it's just something that's always going to be able to be used. We got to get used to that. Okay. All right. Okay. If we take a look at this one, they want us to do a 2-column proof here. Okay. And we're going to be able to kind of use these a little bit. I wish they were closer together, but they're not. So I'm just going to sketch it over here for myself. So I can see it all. I wish I could draw better too. Let's see what the letters are. E, D, F. Okay, so let's go ahead and do this proof, and this should be pretty straightforward. Some key things we got to remember. First off, they're telling me that DE is equal to EF. That was given. Okay. They also tell me that EG bisects angle DEF. That is given. Okay. But remember, when something's being bisected, we have to state it. So this line up here, EG, is bisecting the angle up at top. So I've got, and which angle E are you talking about here? So I've got to really use 3 letters. So angle DEG is going to be congruent to angle FEG. Okay, and that's the definition of a bisector. In this case, it was an angle. Okay, so I've got that. Let's show it. And now I got to prove something else. Now we're learning about side angle side, so we got to think, hey, I got to find another side, and it's got to be a side that creates the angle, or is helping create the angle at least. So that's got to be this line right here, and that line's part of both triangles again. So I should be able to use reflection. So EG is equal to EG by the reflexive property. So now I've got the two sides that are equal. They're creating the angles that are equal. So now I can prove, they want me to prove these two triangles are equal. So now I can use side, angle, side. Okay. So the side, the angle, the side is equal to the side, the angle, and the side. Okay. So don't overthink it. We had a reflexive property there. We had bisector. We should know all that stuff. Should make you be able to do this proof pretty easy. And we're using the new rule that we're learning. So kind of think along those lines. Okay. Okay. So we're going to do a 2-column proof here. 2-column proof here. This is number 1 on the homework. So just really quick, if I show you this one, so you get it. Okay, they got AB is equal to XY and AC is equal to XZ. That's given. also tell me that BC is equal to YZ, and that's given. Okay. So if I look at that, I've got 1, 2, 3 equal to 1, 2, 3. Well, all the sides are equal, so and they want me to prove the triangles are equal. Well, can't I do that? I can. So ABC is congruent to XYZ by side, side, side. Okay, so it's just a bunch of what you have to do. Okay, if you take a look at question 14, kind of did this in class, so I want to give you guys a shot at it too, because there's a unique thing to use that comes from a different chapter that we've done. Okay, so 14 is this guy. No, that's not the right one. I want to make sure we understand too, in 13 you had a midpoint. Remember, that's like bisecting, and you also have vertical angles here too, so just remember that when you do that one. Let me find the one this guy right here is 12. Sorry, got my numbers mixed up. We got to remember here that if you have the arrows being parallel sides, and if you have this issue here with parallel sides, I want you to automatically think, hey, you got transversal stuff going on. So if you remember back to chapter 3, we did transversals. If lines are parallel and all those things that we learned, the different angle groups come together. But specifically, if you see parallel lines, think transversal. If you know that, then I can say that these angles are equal, and I could say that these angles are equal by alternate interior angles. Okay, all the time, 100% of the time. Okay. You also should be able to say that AD is equal to AD by reflexive. Okay, so you got all these things you could think of, but the transversal stuff, sometimes we kind of forget about it if we don't see it. Now it's kind of coming back. So remember, parallel lines make a transversal, and you should be able to use alternate interior angles all the time. And in this case, you're creating two sets of alternate interior angles, so that really will be helpful for you to prove that triangles are congruent. Okay. In this case, it would be SAS, because these are congruent. We proved by reflection, and they told us these sides were congruent. We use alternate interior angles to say that these angles are equal. That's where you get side angle side. Okay? All right. Make sure you get some help if you're not getting it, and make sure you really give a good shot on the proofs. Okay? Thanks.